Okay, so well actually negative and positive values of the cosine. We're going to graph this, our cosine value from, and we'll do it in this case from negative 450 to 450, and we'll graph it in degrees. Okay, so say we had no idea where to start with something like this. One of the very first things we could technically do is we could literally put in our values. So 0 cos is used to be the value of 1. So when x is 0, I know my y value is 1. So I'm going to start right here. Okay. From there, I always lose my calculator very quickly. Our 90 value of cos is going to be 0. And let's try negative 90 cos. That's also 0. So in other words, what's happening is we're going down to 0 and negative 90 and 0 and positive 90 and 0. We'll keep the same thing. Let's try positive 180. Gives us negative 1. And negative 180 gives us also negative 1. So the next value is down here. Down here. 270, what do you think is going to happen?
0 again.
0 again. And then 360,
1.
back up to 1. Yeah. So it looks like it's keeping an identical pattern left and right. Okay, so we'll graph it up to 360 so far. So we have a graph that looks something like this. So going with this pattern, what do you think our 450 would be?
0.
Yeah, back at 0. And negative 450?
0.
0. Okay. So if we take a look at this, say I was to talk about lines of symmetry. This looks like it has actually a line of symmetry right on the y-axis. In other words, all of our x values are flipped in terms of what their y-coordinates are, right? Our 90 and negative 90 are on exact same points. Negative 180 and 80 are on exact same points. So if I were to cut this in the middle and fold it over, it would perfectly overlap what we have already, right? Saying that what we had in our question show that f at theta were equal to all of the values at f at negative theta, right? That was our question.
Yep.
Why is an event like this occurring? Let's go back to our CAS system and see if we can kind of put a little sense to it. So over here in our CAS system, this is quadrant 4, 1, 2, and 3. And we know with our system we have C, A, S, T. Okay. We know that our initial arm normally starts right on the x-axis. Okay. And then we have a terminal arm. So let's talk about those cos values we were actually using. In fact, let's try to use values that are a little less pronounced. For instance, we know that at 90 we're going to have a value of, what is it, 1, you could say, right? 180, or sorry, 90 was going to be a value of 0. And 270, 360, and technically this is also 0 if we're going around in a circle here. Okay? Now, what I want to realize is our cos, okay? Cos is positive in this quadrant and in this quadrant, okay? So let's say we had, for instance, 30 cos, maybe 45 cos. No, neither of them will give us good values. And 60 cos, anything given as a whole. There it is, that's what I was looking for. Okay, so if we have 60 cos, we're looking at a value of 0.5. And if we have negative 60 cos, we're still looking at a value of positive 0.5. In other words, what it's saying is, if we create a triangle here, of this being, let's say, 60 degrees, we're going to get a ratio of 0.5, right? And we know it's going to be positive because all values are positive in this quadrant. Well, if we make another triangle, okay, and this being, again, 60 degrees in this quadrant, we know we're getting a ratio of 0.5, and it just so happens it's going to be a positive value also because they're both positive. So in other words, think of it like our arms, and we'll do two different colored ones. One will be red, and then we'll do one that's blue. No, that's not blue. There you go. Think of these arms as moving. When they're moving in this quadrant, they're always positive here, and that's when we're having positive values of theta, right? This is where we have all our positive values of theta. We go in a counterclockwise direction. So we're starting from the initial arm and going up here. And all of those are positive values of theta. And all of our negative values of theta, okay, so starting at that initial arm but actually going clockwise, happen to have the same effect with cos. They're all going to be positive in this first quadrant, right? Right up until we get to 90 and 270. In other words, positive 90 and negative 90. So this was our positive 90 degrees, and up to the point where we are now, we're at negative 90 degrees, right? Well, once we go into our next quadrant, what happens to cos here?
Becomes negative.
Cos has a negative value. And in the third quadrant, so when we're getting over here, what happens? We have cos of negative again. That's right. So think of it like this. Now that we've entered this quadrant, everything in here is a negative value. And at the same time, when we're using these values, everything in here is at a negative value. And what we really mean by that is, remember, we're creating angles. The negative direction goes like this, and the positive direction goes like this. So if I create those same identical angles, let's say those are like, I'm not sure, 170, okay? Let's say we have this one being negative 170 degrees, and this one being positive 170 degrees. What ends up happening is our cos values, our ratios are both going to give out negative values because of the way the cast system is set up. Okay. Then we get a little bit of an overlap. Oops, keep that there. This guy comes over. Well, he still stays in the negative range. And he still stays in the negative range when we get around. In fact, right up until we get our identical arms to here. Okay. And at this point, we've moved the same amount. We've moved from here, we've moved exactly negative 270 degrees. And up to this point, we've moved from here positive 270 degrees. Okay? Still having the exact same effect because of the cast system. Finally, when we're closing into our 360, we're back in our positive between negative 270 and negative 360. And positive 270 and positive 260 are again in our positive range. So does that make sense how the cast system actually is set up so that our inverted ones or our negative and positive values are going to end up with the same positive and negative ratios? That makes sense?
Yeah.
Okay. So that's kind of what's happening with cos. It'll be a little different with the other values we have.